Guys, in this video I want to show you the solution for problem 1694 norocos. So please read the cherinza. So in the first cherinza you have to find the smallest and the biggest number where the square of the number is equal to the sum of consecutive, like the square of m is equal to sum of consecutive m numbers. So when you think about it, you'll realize that actually any odd number, the square of any odd number is equal to actually the sum of that many numbers. So for example, the square of 3 is equal to consecutive 3 numbers. The square of 5 is equal to the sum of consecutive 5 numbers, and so on. So basically, in Cherinza Uno, you will go through the array and you'll read your number m, and you want to find out if your number is odd number, and if this one is smaller than minimum, then you have your minimum number. And you must also check if that number is odd number and is bigger than maximum, then you have your maximum odd number. So after you finish your loop, if maximum is equal to 0, it means that you never found an odd number. In that case, you print 0. But in other case, you print the minimum and the maximum number. Now let's go to the second cherinza. In the second cherinza, you must find the number. You must find out how many numbers are, for example, 3 norocos. What is 3 norocos? You call the number 3 norocos if the number is equal to the product of distinct 3 prime numbers. So if you just try for number m, if you try all the numbers and check one by one if they are prime, you will simply get limited timp pashito. So what can we do? Actually, here you can use the prime factorization method. So I will create a function k norocos, where as a parameter I will pass the number itself and k, how many times it must be multiplied by the prime numbers. So let's look to the function. So in this function, this is the number and this is how many prime numbers it must have. So you start counter by 0, and if the number is divisible by 2, since 2 is a prime number, you divide the number by 2 and you increase the counter by 1. If it's still divisible by 2, it means that it has more 2's inside of it, so it doesn't fit our case, so you return false. It's not k norocos. If not, you will start from the 3 and go until the square root of the number, and each time you will increase I by 2. And if x is divisible by I, again you will divide x by I and increase the counter. After doing this, if it's still divisible by I, it is like the scenario here, you return false. Or if the counter exceeds, if the counter is bigger than the actual k, in our case it's y, again you will return false. After all this, since we are going until the square root, you will be remained with the biggest prime number, which is the divisor of it, and if it is bigger than 2, it means you have that biggest prime number. Then you increase the counter, and finally, if the counter is equal to y, you will return true, else you will return false. Please read the old documents that I gave you to better understand what is prime factorization. And that's the solution. Actually, it's very pretty and simple solution. So this problem was asked in Olimpiada Nazionale 2016. And if you do this way, you'll get 100 points. Good luck, guys.